When you talk about relative speed, we have two types. Number one is relative speed for bodies moving in the same direction. Number two is relative speed for bodies moving in opposite direction. For today's class, we are going to cover relative speed for bodies moving in the same direction. Now, before we even move on, how will you define relative speed? Relative speed, by definition, relative speed is simply how fast how fast an object appears to be moving with respect to another object. So here is a comparison between two moving bodies. If you compare two moving bodies moving at the same time, then you can determine how fast is one of them moving in comparison to the other object. Now, we are going to talk about relative speed for bodies moving in the same direction. If bodies are moving in the same direction, then how do we get the relative speeds? If we have one body is moving at maybe 30 meters per second, and another one is here moving at 40 meters per second, then you have to determine which body is moving faster than the other and by how much. If this is body X and this is Y, then you have to determine which of the two between X and Y is moving faster than the other. And then you determine by how much is that particular body moving faster compared to the other one. If you look at this, between 30 and 40, 40 is at higher speed, meaning Y is moving at a higher speed compared to X. But at how much? At what speed? So the difference between them, you need to know by how much Y is moving faster than X. You get that it is 40 meters per second. Subtract 30 meters per second. Then this one gives you what? 10 meters per second. So it means that Y is moving at 10 meters per second faster than X. Now, in short, it means that if bodies are moving in the same direction, then relative speed is given by the difference between the two speeds. So you have to note this, that if bodies are moving in the same direction, then relative speed is given by the difference between the two speeds, as we can see in this particular illustration. Question 1. A lorry 50 meters long travels at a speed of 40 meters per second, moving parallel to a train of length 120 meters long and travels at a speed of 20 meters per second. Find the time taken for the two vehicles to overtake each other. So here, one thing you need to know is to first of all get the distance between the two vehicles. Now, in the case where you are given the length of the moving bodies, and even the distance between them, then the distance covered will also include the length of the body. So therefore, total distance in this case is going to be the length of the two bodies. The first body, which is a lorry, was 50 meters. Add the length of the train, which is 120 meters. And then you need also to add the distance between them, if given, right? A lorry 50 meters long travels at a speed of 40 meters per second, moving parallel to a train whose length is 120 meters long and travels at 20 meters per second. Now, in this case, we are just given the length of the vehicles and are not told how far are they apart. So therefore, we are going to assume that the distance between them is therefore the sum of the length of the two vehicles. So this one gives us what? 170 meters. Now, the lorry was moving at 40 meters per second and the train is moving at 20 meters per second. So which of the two vehicles is moving faster and by how much? That is now when you're now comparing the two speeds to get the relative speed. So relative speed is going to be the difference between the two speeds. So you take the bigger speed 40, subtract the smaller one 20, and this one gives you what? 20 meters per second. So now we are being told find the time taken for the two vehicles to overtake each other. So time is normally distance over speed. So that is going to be 170 meters over 20 meters per second. Meters and meters will cancel. So this one gives us 170 over 20. And this one is equal to what? 8.5 seconds. So therefore the time taken is 8.5 seconds. So this one is also called relative time. Example 2. Two buses A and B of length 8 meters and 12 meters respectively are moving in the same direction along a straight line. Bus A is 20 meters behind bus B and moves at 18 meters per second, while bus B moves at 13 meters per second. Calculate the time taken for bus A to completely overtake bus B. Find the distance traveled by bus A during the overtaking. Now in this case, we have bus A and bus B, and the length of the buses are given. A is 8 meters and B is 12 meters respectively. And then we are told bus A is 20 meters behind bus B. So therefore we are also given a distance between them. So therefore total distance to answer part A, calculate the time taken for bus A to completely overtake bus B. They are moving in the same direction. So therefore distance between them is going to be their length, that is 8 meters plus 12 meters plus the distance between them, which is 20 meters. The sum of this 8 plus 12, that is 20 plus 20, that gives you 40 meters. And then relative speed, the difference between the two speeds. So we have that A is 18 meters per second and B is moving at 13 meters per second. The difference between that is 5 meters per second. So therefore time, that is also called relative time. Time for overtaking is also called relative time, is equivalent to relative speed, total distance, which is 40 divided by speed. So that is 40 meters divided by 5 meters per second, which is equal to 8 seconds. So it will take them 8 seconds. 8 seconds to overtake. That is for part A. Part B, find the distance traveled by bus A during overtaking. So bus A was moving at 18 meters per second and it took 8 seconds to travel. So therefore distance is equal to speed times time. The speed of bus A is 18 meters per second. The time taken is 8 seconds. So that is going to give us, so you take 18 times 8 and that one gives you 144 meters. So bus A had to travel 144 meters to be able to overtake bus B. Example 3. A train P, 120 meters long, is moving at 25 meters per second. Another train Q, 80 meters long, is moving in the same direction at 15 meters per second. If train P is 100 meters behind train Q, calculate the time taken for train P to completely overtake train Q. So let us find the total distance between them. And I said, if you're given the length of the bodies and the distance between them, then you need to add the two lengths plus that particular distance to get the total distance. So therefore total distance, which is also called relative distance, is going to be 120 meters plus 80 meters plus 100 meters. So this one should give us 300 meters, because 120 plus 80 is 200 plus 100, 300. Then relative speed is the difference between the two speeds, so that is going to be 25 minus 15 give you 10 meters per second, and therefore relative time, which is the time taken for the two vehicles to completely overtake each other, is going to be relative distance, which is the total distance, over relative speed, and that is going to be 300 meters over 10 meters per second. Meters and meters will cancel, and we give this to be equal to 30. We take them 30 seconds to overtake. So the answer is 30 seconds. So question 4 and 5, I wanted to try. Question 4. Let us see another class of questions coming from this, a different way in which the same concept can be tested. So two trains A and B moves in the same direction along state railway line at a speed of 24 meters per second and 16 meters per second respectively. Train A is 120 meters long while B is 80 meters long. If it takes train A 35 seconds to completely overtake train B, calculate the initial distance between the two trains. It means that there was some distance between them. So that the total distance should be, that is, we were saying the relative distance should be the length of the two trains. The first one is 120 meters, the other one is 80 meters, and let's say that the distance between them was x. So 120 plus 80 plus x, that one gives us 200 plus x meters. So this becomes the distance between them. And then we are told the speed of the two is 24 and 16. So we can now get relative speed. Relative speed is going to be the difference between the two speeds, 24 minus 16. And this one gives us 8 meters per second. We're told that if it takes train A 35 seconds to completely overtake train B, meaning already we have been given the relative time overtake is 35 seconds, and we know relative time is equal to relative distance over relative speed. So let us now equate them. That 35 seconds is going to be equal to relative distance is the same as total distance, 200 plus x divided by relative speed, which is 8 meters per second. So therefore cross multiply, we shall now get that 8 by 35 is equal to 200 plus x. And if you take 8 times 35, that one gives you 280. So 280 is equal to 200 plus x. So what is x? X is 280 minus 200. So therefore x is what? 80 meters. Example 2. A car moving at 30 meters per second overtakes a lorry L moving in the same direction at 20 meters per second. The lorry is 12 meters long. If the car is 18 meters behind the rear of the lorry and it takes 4 seconds for the car to completely overtake the lorry, find the length of the car. So here we are now finding the length of the car. So total distance will be the length of the two bodies plus the distance between them. The lorry is 12, the car is 18 meters behind, and the car is x meters long. So 18 plus 12, that is 30. So this is going to be 30 plus x as the total distance. Relative time is 4 seconds. Relative speed is the difference between the two speeds, that is 30 and 20. 30 minus 20. This one gives us 10 meters per second. So now let us make this equation that relative speed, relative distance over relative speed should give us relative time, which is 4 seconds. So therefore, relative distance is 30 plus x over relative speed is 10 seconds should be equal to 4. Cross multiply. 30 plus x is equal to 40. So therefore x alone is 40 minus x. 40 minus 30. So x is going to be 10 meters. The last one. Two cyclists P and Q of length 2 meters and 3 meters respectively cycle in the same direction at 7 meters per second and 4 meters per second. Cyclist P completely overtakes Q in 5 seconds. Determine the distance between the cyclists at the instant the overtaking began. So now, total distance is the length of the two, that is 2 plus 3 meters. The distance between them, let's say x. So this one is going to be 5 plus x meters. Relative speed is the difference between the two speeds, that is going to be 7 minus 4, and this is 3 meters per second. And then we are told that relative time, that is the time it took the two bodies to overtake each other, is 5 seconds. We know that relative time is equal to relative distance over relative speed. That is 5 plus x over relative speed is 3 should be equal to total time taken, which is 5 seconds. So cross multiply. 5 plus x is equal to 15. So that x is equal to 15 minus 5. So x is therefore 10 meters. This one you try out. Question form. So try that. Let's meet later for another type of questions on relative speed.